Hey there, Hampshire chemistry students. In today's video, we're going to be taking a look at some example stoichiometry problems. And we're not just going to be involving moles this time, we're also going to be involving grams, molecules, and even getting into volume, connecting our big ideas here. Let's start with a simple one though. Hey, I have an equation that needs balancing. This is a bit of a trickier one. Give it a shot. See if you can balance our equation, and then we'll try out our example problem here together. Give it a shot. So when balancing this guy, we might have noticed that we needed a big old 2 out in front of here. Hey, that's going to affect our amount of carbons and hydrogens. Okay, so that means we're going to have 34 total oxygens on the right-hand side. So I'm going to need 17 as my final balanced equation. Okay, a bit of a tricky balance, but once you have it balanced, a problem like number 1 here should be pretty easy. Hopefully you've got this down in your notes with me, and you've already got it started or started thinking about it. We're starting with our 77.6 moles of CO2. And if I want to convert that into moles of oxygen, thankfully we have our lovely equation that tells us for every 10 moles of CO2 that we will be creating 17 moles of oxygen. Okay. Make sure you're setting up and showing your work here. So I'm going to take my 77.6 times 17 divided by 10, and that will tell me that I will have moles of O2, because the moles of CO2 cancel, and we would end up with about 132 moles of O2. This should be pretty straightforward from what we've looked at so far. So let's kick it up a notch. We're going to use the same formula, okay, with the same balanced equation, except this time we're asked for how many liters of O2 we have. So I'm starting with my moles of CO2, and I somehow have to get these into liters. Thankfully, we can remember some of our key conversions here. That if I have 1 mole is going to be equal to 22.4 liters at STP. That might be helpful. Remember our other couple of examples here, that we are going to be equal to 6.02 times 10 to the 23rd atoms or particles. And our last example of a conversion we might do would be if we were doing a gram conversion, where we would have molar mass. So all these different parts come together here. I'm going to need to convert my moles of CO2 I can't convert them directly into liters, but like we just did in the last example, I can turn those moles of CO2 into moles of O2. And then those moles of O2 can be converted into whatever we want. You'll find that when we're in stoichiometry, you can convert any substance into another substance, but you must include a mole-to-mole conversion. This step of moles to moles will always be our heart of stoichiometry. Let's set this up and see how this is going to look, because this is going to take 2 steps of math that we can combine together here. So 77.6 moles of CO2. And there's our first step. Let's already pre-set up our second step so that we are ready to go here. We know that we have 10 moles of CO2. And we have 17 moles of oxygen. And notice that this is the exact same setup as our last problem, 17 and 10, because we're still dealing with CO2 and oxygen. The big difference here is that in our second step, we want to take those moles of O2 and convert them into liters of O2 when we're at STP. So, thankfully, we know that amount, right? 1 mole of any gas is equal to 22.4 liters. So, I'm going to take my starting amount again, multiply by 17, divide by 10, multiply by 22.4, divide by 1, and I'll get my final answer here for my liters of O2. And we should get 2960 liters of O2. So notice, we are combining our idea of our mole conversions with our older conversions, right? We've already done liters and different kinds of conversions here together. It's all about those different pieces. So let's take a look at one last example here together. Same formula, same conversions, but notice that here we are asked to find how many grams of H2O are created when 150 grams of my C5H14 reacts. Ooh, so what is our setup going to be here? Starting with my grams of C5H14. I want to turn them into grams of H2O. We need a mole-to-mole conversion. That is our heart. So at some point, I must convert my moles of my C5H14 into moles of water. Okay, this step is required to go between these two chemicals. And all I'm doing here is I'm going to take my grams and get to that mole conversion. So my grams will become moles of C5H14, turn those into water moles, and finish up ending with those in grams of water. This will take 3 steps. We're starting with that 150 grams of C5H14. You're going to need to do 3 steps of math to get our final answer. When I plug these in, hey, you're going to want to make sure your units cancel. My grams of my C5H14 will become moles of C5H14. In our second step, we're going to do our mole-to-mole conversion. So I'm going to bring down my diagonal unit here, moles of C5H14. That will become moles of H2O. Our moles of H2O will come on down. Notice how everything's going to end up canceling here, and we're going to end up with grams of H2O on the top. Look at that canceling. Grams to grams becomes moles. We go from moles of one chemical to moles of another. And then moles of our water to grams of our water. We then need to plug in and set up. 1 mole, we know, is equal to grams in molar mass. So I need to find my molar mass to save us some time. It's going to be 74.19, right? The mass of 5 carbons plus 14 hydrogens. I then need to know my conversion. Hey, we know this from our formula. 14 waters for every 2 C5H14s. Lastly, we need to do our gram to mole conversion. So, 1 mole of H2O would be equal to its molar mass. This one's going to be 18.02. So plug and chug your favorite numbers here to help you get your final answer. And you will end up with an answer in this problem of 255 grams of H2O. We will look at more examples and try these out coming soon. These are some of our most complex mathematical problems, but each step breaks down to what we've done before. Thank you for watching, and I'll see you in the next one.